All right. Okay. Hold on one sec. Let me get everything out of the way here real quick. All right. So I am Kenneth Fisher, and we're going to do SQL Server security basics. Little bit about me. I have been a DBA my entire career, which is longer than I'd really like to talk about. I have been doing SQL Server for the last 15, 16 years. Before that, I worked with such things as Clarion, FoxPro for DOS, if anybody remembers what DOS is, and FoxPro for Windows. So my contact information, I'm SQL Student 144 on Twitter. I'm very active on Twitter. You can also get me at sqlstudent144@gmail.com, and I blog regularly at sqlstudies.com. Now you'll probably notice a theme there. I do give homework. There will be a quiz. All right, so I know this is a webinar, but I'd like everybody to start out. I want everybody to raise your hand. Yes, that includes you at the back. So who here is responsible for SQL Server security? All of us. Everybody here is responsible for security. I don't care if you're a developer. I don't care if you're a DBA, a manager. Honestly, you could be the person that cleans the carpets at night. We all share some level of responsibility for security, for the security of our data. A few years back, the company I worked for, we started merging. It's a very large company, and they started merging in a bunch of divisions, and teams started getting responsibility for more and more servers. Now, one of the things that we noticed as we started picking up these servers is that they were doing it wrong. And in fact, as we picked up more of them, we discovered that they were all doing it wrong, and they were all doing it wrong in different ways. Now, to be fair, we were doing it wrong too. So I don't want anybody to think we were perfect. But it made me realize that particularly with security, there's a gap. Unless you've really made an effort to learn security, most people, they learn the simple statements, they learn the simple permissions, and they move on. It's not exactly a fun subject like high availability or performance tuning or internals. So what we're going to do today is we're going to assume that everybody here has absolutely no knowledge of SQL Server security, and we are going to get to a working knowledge. And we're going to do that by starting out with definitions. I'm a big fan of starting with definitions because if we're not using the same language and we're not working with the same terms and using them in the same way, then we have miscommunications, we get confused, we make mistakes, and it's really a very simple thing to avoid. So we start there, and once we're all speaking the same language and we're all on the same page, we're going to move on to the GUI. When you start with a new language, when you start with a new database system, most of the time you'll start with the GUI, or at least I know I always do. And we're lucky. Microsoft has provided us with a great GUI. SQL Server Management Studio is really an amazing tool. The security in it is not always the easiest to find, so we're going to start there, we're going to go through it, and we're going to figure out where everything is. Then, as you become better with SQL Server and with anything, you'll learn to script. Scripting, it's faster, it's easier, and honestly, there's just a lot you can do scripting that you just can't do using the GUI. But the GUI does have some great options to help you learn how to script. So we're going to touch on that briefly as well. And last but not least, we're going to hit some best practices. Best practices are guidelines. They are suggestions by some very smart people who spent a lot of time and effort figuring out what works best most of the time, and testing and so on. Be aware these are guidelines. These are what works most of the time. We need to know them. We want to start there, but you have to be aware that sometimes you have to move away from the best practices when they're just not working for you. So starting with definitions, we have principals, we have securables, we have permissions, and we're going to start right in at the bottom with permissions. A permission is what you want to do, okay? I want to come into your house. May I? I want to run a select against the table. I want to update a table. I want to run a store procedure. Every object in SQL Server has its own set of permissions. Some of them cross over, though some of them don't. So there are a lot of permissions available in SQL Server. I do not expect anybody to have them all memorized. Some people do, most don't. But what we've got here is a nice little sample of commonly used permissions. We're going to go through them real quick just so you get a feel for how they're named, how they're used. And so getting started, tables and views, we have select permission. Select permission lets us run a select statement. Nothing more, nothing less. Insert permissions, we can run an insert statement. Update, update statement, delete, delete statement. Store procedures and functions, we can execute them. All fairly simple. View definition, not quite as clear. View definition lets us look at the code behind a code-based object. Note, this does not apply to CLR, extended store procedures, or encrypted store procedures. But for everything else, it's what lets you look at the code behind a view, behind a store procedure. And in fact, if you have the right permissions, you can look at the code behind a lot of the system store procedures and system views, and you can get a lot of really interesting information that way. At the database level, we have Connect. There's also an instance level Connect. It has been renamed in later versions of SQL to Connect SQL to differentiate the two. All that does is I can come into the house. I can't look at anything, I can't touch anything, I can't go anywhere. You can connect to that database, you can connect to that instance, that's it. That's all that permission lets you do. Backup lets you run a backup statement. Create procedure is a little different. Most people would assume that create procedure lets you actually create a store procedure, and it does, but this is one of those cases where in order to perform a task, you have to have more than one permission. So in the case of create procedure, create view, create table, etc., you not only have to have the create permission, but you have to have alter on a schema. Schemas are the containers for most of the objects within a database. So basically, you have the create permission, lets you create the object. The alter on the schema gives you a place to put it. All right, view database state, and there's a view server state as well, lets you read from the DMOs, database management objects, that have information about the database and server state. All right, so homework part one. You see that little image there in the bottom right corner? This one right here. There's a link there to a really great poster on SQL Server permissions. When you get the chance, tonight, tomorrow, download the slide deck, follow the link, download the poster. I wouldn't expect anybody to print it out and stick it on your wall like I did. But have it available as a reference. It's a very handy tool. All right, securables are objects. They are what we want permissions to. Most securables in SQL Server are also containers. So for example, a database is a container. It contains schemas. Schemas are containers. They contain tables and stored procedures and functions and views, etc. Tables, believe it or not, are containers. They contain columns. And you can, in fact, do column-level security. That being said, in my entire career, I have never once done column-level security. There is a lot easier way to manage the same task, and we'll go over that a little later. Now, when you apply a permission to a container, you are effectively applying that to every object within that container. So, for example, if I grant execute at the database level, I am effectively giving you permission to execute any store procedure or function within that database, schema within that database. If I grant select permissions at a schema level, that means that you can run a select statement against any table or view within that schema. And that's an important thing to remember. Another important thing is that instances are securables. They are also containers. They contain databases. The permissions, however, at the instance level do not act like the permissions at the database level and lower, in that by granting a permission at this container level, at this instance level, you are not granting anything below that. So, for example, older versions of SQL, you had connect. Again, it's connect SQL now. But that didn't mean that you could connect to any databases, just that you could connect to the instance. There are some newer permissions, connect any database, view any definition, that do actually give you permissions within all the databases on the instance. There are more coming out each version. They're kind of handy to have. But those are the exceptions, not the rule. Principals. Principal is who wants to do something. So I want to come in the house, I would be a principal. This user wants to run a query against a table, the user is the principal. And there are lots of different kinds of principals that all break down into two categories, server and database, otherwise known as logins and users. Now, I am not overly fond of the term login and user. Those are the correct terms. I mean, it's create login and create user, but I don't particularly like them because they're very overloaded. Okay, I'm a user, and in spite of what I said a second ago, I'm not actually a principal, a database principal. I have an Active Directory login that I use when I connect to my network every morning, but it has absolutely nothing to do with SQL Server permissions. And in fact, it could be called an Active Directory user, depending on who you're talking to, because the terms are pretty much interchangeable. So my suggestion to you is when you're thinking about database security, think in terms of principles, use the term user, but just in your head remember that you're working with a server principal or a database principal, and that'll help you keep them a little bit more straight. So types of logins and users. We have SQL logins and SQL users. We have Active Directory logins at the server and database level, and Active Directory and Windows groups at the server and database level. We have logins and users mapped to certificates and asymmetric keys. And we have roles. Roles are not logins and users, but they are principals, and there are server and database level roles. A role is a specific type of principal that is a container for other principals. So we apply permissions because it's a principal, and we add members to other principals that we add to this one, to this role, and then any permissions that we granted to the role are effectively granted to any member of that role. There are two types of roles. We have built-in roles. These are at the server level, things like sysadmin, security admin, backup admin, etc. At the database level, you'll see DB owner, DB data reader, DB data writer, DB deny data reader, DB deny data writer, etc. And these are also called fixed roles. They are fixed because we can't change them. You cannot grant or deny any permissions to these roles. They are now and forevermore, unless Microsoft decides to change them, what they are. However, there are some built-in roles that Microsoft installs with the product, so they're built in, but they are not fixed. These are found in MSDB. In MSDB, there are something like 12 to 15 roles, and I can't remember exactly, but they are for things like controlling access to SQL Server agent, to SSIS, in older versions, DTS packages, etc. These roles aren't fixed, okay? You can actually change the permissions on them, and if you do, what will happen is the DBA gods in their server on high are going to mark you down for punishment. And I'm not kidding, I wish I was. What will happen is at some point, in a year, in 2 years, you're going to grant permissions in a development environment, and it's going to work beautifully. And you're going to do the same thing in your test environment, and it works exactly the same way. And you move on to your production environment, and it does not work. And you will spend hours or days trying to figure out what's wrong, why this permission, this role that works perfectly in development and test doesn't work in production. Only to find out that at some point a few years back, somebody was running a script that changed the permissions on these roles. If I sound a little bitter, there are reasons for that. I actually had to deal with this recently. So don't change the built-in roles, okay? Even the ones that you can change, don't touch them. So if we can't change some and we shouldn't change the rest, what do? We use our user-defined roles. These are the roles that we create specifically for ourselves to be able to add and remove permissions easily. All right? Now, one of the neat things about user-defined roles, remember that roles are principals and they are the containers of principals. This means that roles stack. That means that I can have a role called users that has read permissions on 10 tables and write permissions to 5 of them. I can then have a second role called admins. It has write permissions to the other 5 tables, and it's a member of the users role. So any member of the admin role now has read and write permissions to all 10 tables. So you can segregate your permissions even more easily by creating them at various levels and then stacking them together. All right, so homework 1B. Same thing down here. We have an image, right? Looks like a poster. It's a poster. This is Microsoft's poster on built-in roles. There's actually 2 of them, one at the server level, one at the database level. Again, very, very handy reference items. They're nice visual look at how the built-in roles stack together and work. Okay. Now, it should not come as a surprise to anybody that we work in a relational database management system, an RDBMS. And it certainly didn't come as a surprise to Microsoft. All of the data that we work with, the tables, the columns, everything is stored in tables, in system tables. We do not actually have access to those system tables, except in very specific circumstances. What we do have access to is system views, system functions, system stored procedures. These 6 system views are all of the contain all the information that we've been talking about so far. And they are a great way to look at this information and to help you remember this information. So, homework part 2. When you have time, go in, run some selects on these, join them together, take a look at the data. Just the names on these things is going to help you remember you have a server level principal, you have a database level principal, you have permissions at the database level and at the server level, and roles have members. This is a great way to reinforce what we're talking about today. But this isn't all of it, okay? There are other views and functions out there that have some great information about security. Homework part 3. Find some, okay? Do some research, take a look, see what you can find. And each time I give the session, I pick one view or function. In this particular case, I want you all to go take a look at sys.login_token. It's not in my notes anywhere. This is specific to this session, sys.login_token. Take a look at it, see if you can figure out what it does, figure out how to use it. If you're a DBA, see if you can figure out how to use it on other people's logins. And if you run into any problems, tweet me, email me, go on my blog, make a comment. Like I said, I'm on them almost every day, and I will respond. If you have any great successes, even if you have what you feel like is a moderate success or a simple success, let me know. I'd love to hear about it. And very honestly, I'm still learning this stuff too, so it may very well be that you figured out something that I had no idea. And I'd love to know it. I'd love to hear about it. Okay, so since we're working with system tables, since our data is all in system tables, and we all know relational databases, we have to have a key that ties them together, right? So what ties our server principals and our database principals together? Well, if you go back and you look in your server principals and database principals tables, you will find 3 columns that are identical. The first one is the principal ID, and the principal ID is not the key between the two. Best I can tell, it is an identity column. It certainly increments each time you add a new login or a new user, a new server or database principal. Because every time you add a server principal, you might add that server principal as a database principal in one or more databases. The chances of those IDs being the same between the two sets of information is pretty slim. So it is not the principal ID. It is also most emphatically not the name. I have worked in systems where the names are, needless to say, confusing. You by no means have to have the name at the server level and at the database level be the same, but I highly recommend that you do, because we're people, we look at names first, numbers second, and so even as recently as the last week or so, I've gotten caught on the fact that a database principal name and a server principal name didn't match up, and I spent 20 minutes looking back and forth trying to figure out what was wrong, when I finally remembered that they don't have to be the same, they just should be. So I highly recommend keeping them the same, but they are not actually the link between the two. And that leaves us with the SID, the SID. And the SID is, in fact, what ties server principals and database principals together. It is a var binary. You'll notice that different types of server principals have different lengths. You have SQL logins, and the SID for a SQL login is created by SQL Server, and it is one length. Active Directory and Windows logins and groups are a different length SID, and that's because they're created by Active Directory or Windows. And then you have SIDs for certificates. Those are actually a hash of the public key, and yet again, a different length. Now, sometimes we lose our SID, or at least they don't match. And when that happens, we get orphaned users. And if you have not dealt with orphaned users before, I promise you, you will, and you won't enjoy it. You might be a DBA who has an irate developer or irate users who should be able to connect, used to be able to connect, and now they can't. You might be that irate developer or irate user. Orphaned users are a thing. They happen more often than you'd like. You just have to deal with them. One of the most common reasons for an orphaned user is when you have to copy a database from one server to another. Now you copy the database, but you'll notice the server principals didn't follow through. There are no logins associated with these users. So if we're working with Windows authenticated users, all we have to do is we create our login from Windows, and we're golden. We not only have our login, but we have our SIDs that match. But what happens when we're working with a SQL Server authenticated user? All right, this time we copy our user over, and we create our login, create login dopey with password. Well, we have a problem though, because you'll notice this time nothing's tying these together. That is because when we created our login, we got a whole new SID. Remember, SQL Server creates the SID. So when we created our new logins, the SIDs do not match the ones that were created on server A. Okay? To fix that, pretty simple to fix. In older systems, SP change user's login. In newer systems, alter user with login, and we fix the SID. It reassociates the two. Now, that's great. But what happens when 2 weeks from now the developers would like you to refresh the database again? Let's say server B was development and server A is test, and they want you to refresh development from test. So you copy your database over. And your users call you, your developers call you, I can't log in. Oh, that's right. I forgot to fix the SIDs. We have orphans. And you feel a little silly for forgetting because, I mean, you've been doing this for years, so you wouldn't think you'd forget, but it happens. And you promise never to do it again. And then a month or so later, they'd like you to refresh it again. And guess what? You forget. And the developers call, we can't log in again, you forgot. Oh, that's right, sorry, fixed. And this time you're feeling a little stupid, and honestly, they're starting to wonder a little bit about you themselves. So what are we going to do to fix that? And there is an easy way to fix this. So this time, we copy our database over. But now, when we go ahead and create our login, specify the SID. One of the options, and this is not in the GUI, okay, this is again one of those things where you have to learn how to script, but one of the options, you can pass in a SID. So if you get the SID from server A and I put it here, then when you create it in server B, it ties together. Now, don't worry too much about how I get the SID, how do I create this. There are lots of scripts out there. SP Help Rev Login is one that Microsoft provides. I believe Robert has a couple on his blog that'll do it. I've got a few on mine. They're very, very easy to find. So just go online, look up copying logins from one server to another, and you'll easily find a script that will create this command for you with the SID so that you don't have problems with the orphaned users, or at least hopefully not as many. Okay, there are exceptions. As with any rule, there are exceptions. There are cases where it doesn't matter if the SID matches up between the database and the server level, okay? Exception number one, roles. I don't care if the SIDs do match, although I don't think it's possible. Server level roles and database level roles have absolutely nothing to do with each other, okay? Exception two, contained databases. Now, this is Microsoft's solution to copying that database over from one server to another and constantly having to mess with orphaned users. So when you create a contained database, all of the information for your database principal and your server principal is contained within the database. There are not actually logins and users, it's all just a user, but the information that you need, for example, passwords, are stored within the database. That way, when you copy that database over, everything goes with it. All right, so we have permissions, we have securables, we have principals. How do we link them all together? All right, well, to start with, we have grant. Grant applies a positive permission. All right, so if I grant select on a table to a principal, then that applies that select permission, and they can now run select statements. Deny. Deny is the opposite of grant. It applies a permission, okay? Don't get confused about this. It does actually apply a permission. It is just a negative permission. You cannot do that. So if I deny select, you can't run a select. Now, the opposite of grant and deny combined is revoke. Revoke actually removes a permission, and it will remove a grant or a deny. If you want to prove this to yourself, it's very easy. Go look at those system views that we were talking about earlier. Run a grant, run a deny. You'll see them both pop up in the permissions table, in the permissions view, and then revoke them, and you'll see them removed. So this is another one of those things where people get confused. Remember that grant and deny are opposites, but they both apply a permission. Revoke is the opposite of both of them, and it removes a permission. Now, every time I've had somebody check my deck for me, which I've had done a few times, every single time they always mention that I've made deny bigger than grant, that I've used a different font. And that's deliberate, and that is because it is another one of these things that people get confused about, and it's really, really important to remember. Deny trumps grant. You can have one deny and 100 grants that you have got at the schema level, the database level, that you have got through 47 different roles at all different levels, and if you have one deny, that's it, you're done. You can't do it. So remember, if I deny you a permission, it doesn't matter what else I do, you cannot do that task. So my recommendation to you is limit the number of denies you use. You do have to use them occasionally, but what will happen is you'll periodically grant somebody a permission and they won't be able to do it. And one of the first things I do is go looking in the system views for any denies And then I start tracking back, and if I've got to deny somewhere, does it actually relate to this person? Does it actually relate to this object? Because chances are, if you've granted them the permission and they still can't do it, there's a deny that you're not seeing out there somewhere. All right, last but not least, and then we go into our next bit, administrative principles and permissions. These are important. These are your super users. These are the ones that when an auditor comes in, they want a list. Reality, generally, they just want to know people who have sysadmin. If I'm an auditor, I want to see all 6. I want to know who's got access. Because each of these has complete control over its associated securable. Okay? So everybody knows what SA is, and everybody knows what sysadmin is. These are your super users. Sysadmin being the role, SA being the server principal. Then you have at the database level, comparable, you have DBO. This is the database owner. There's only one database owner. Okay? When you create a database, when you restore a database, by default, you will be the database owner. When you go look at the properties, that'll have one person, owned by whoever. Then there's the role, DB owner, that grants pretty much the same permissions. And then you have, at a permissions level, you have control server or control database. Again, even control server, somebody who has control server has complete control over the server. Control of a database, they have complete control over the database. They actually have a little bit less in that control server, for example, can't add members or remove members from the sysadmin role. But that's insignificant. You need to know who has these permissions and who's a member of these roles and who has the SA password and who's actually the database owner, because these people have a lot of power and you need to keep a close eye on them. All right, so now we're going to go to our demo. And Robert, can everybody see my Management Studio?
Yes, I see it.
Awesome. All right, so remember, we have server level permissions, we have database level permissions. So we're going to start at the server level and work our way down. All right. When you are looking at these things, this tab right here, the security dropdown, this is where all of our principles are, okay? Everything else is securables. And in fact, there are some securables even under the security tab. But our principles are logins, server roles, okay? And we're going to go take a look at one of our logins, and we're going to pick Dopey, or we're going to go with Doc. So you double click, or you can right click and go to properties, and this is what you're going to see. And you'll notice Windows authenticated, which means I don't need any password information, not mapped to a credential. This is the roles at the server level that this user is, or that this login is a member of. User mapping. This is a great tab, okay? It has its limitations, but it's really cool. Notice that Doc, the only database that he has access to is test. And on test, he is a member of the DB data reader role and the public role. Okay? If I wanted to add him to AdventureWorks, all I have to do is click on Map, and I can grant him membership of roles as well. Note, this is only going to create a user and add him to roles. It doesn't mean that I can do anything else. Now, remember how I told you we're also going to learn how to script. So if you look up here, there's a script button, and there's a little download or a little down arrow next to it. All right? If I click on the script button, it'll do the default version. I'm going to click on the down arrow. Default is script action to new query window, but I could also do it to the clipboard, to the file, or even to a job. But we're going to go ahead and do it to a new query window. And notice we now have a script that creates the user, adds it to the data reader role, and adds it to the data writer role. All right, so now we can very easily see this is how we do it. And if you save the script or you memorize it, now you know how to write a create user for a Windows authenticated login. If I wanted to do the same thing for a SQL authenticated login, I could go to a SQL authenticated login and do the same thing, hit the script button. For now, though, we are going to take a look at more permissions at the server level. One of the things that I don't like is the fact that your principal information, your permissions for your principal and your permissions for your securable are kind of separate. They're not quite as easy to find as you'd like, at least not all in one place. So we're going to go ahead and look at the properties of this securable, the instance itself. And when we are looking at the properties of a securable, there will always be a permissions tab. Okay, this is not role membership, this is specific permissions. So, for example, we go down to doc. Doc actually has administer bulk operations. That is a server level permission. Let's see if he's got anything else. Yes, he does. He has connect SQL. That means he can connect to the instance. All right, so another neat thing that you'll see, again, all these screens are going to look very similar, but one of the other neat things is this effective tab right here. So if I click on the effective tab, I can see he has administer bulk operations, connect SQL, and view any database. He could have these permissions through role memberships as well, and it's still going to show it here. All right? So this is a very quick and easy way to see what permissions do I actually have, regardless of what I'm seeing under the explicit tab. Okay? So moving right along, we are going to move on to the databases. Okay, so within the test database, there is also a security dropdown. And again, all of these are securables with my principals right here. So we're going to start, since we just looked at the instance permissions, we're going to go and look at the database permissions. And again, remember, permissions tab. And here's doc. And we should see, let's go over to effective. Okay, so he's got connect, create certificate, select, and update at the database level, meaning he can select from any table, update any table. So going back to explicit, let's skim down here real quick and see what he actually has explicitly listed. Connect, I would expect that. Create certificate, again, not terribly surprising. And update. But what you don't see is the select permission. Okay, so here it is right there. You'll notice he does not have that granted explicitly, and yet effectively he's got it. And we'll go take a look at why in just a second. But again, remember, permissions tab on any securable. Oh, and if I'm going to make changes, let's do that again here real quick. So if I'm going to grant show plan, all right, but I want to know how to do that for later, I'm going to hit that script button. The script button is your friend. And I now have my script to grant show plan to this user. Notice you have to be within the context of the right database or you're going to end up granting show plan to master, which happens a lot by accident. So looking in at, let's look at roles this time. Database level roles, and we're going to go ahead and look at DB Data Reader. Right click, go to properties, or again, we can on principals, we can double click. And notice that the members of this role include doc, and that's how he had that select permission that we saw earlier under the effective permissions. And a role can also own schemas. We're not going to go into that today. And let's go take a look at doc himself. All right, at the user level, we have the user's name, the login's name. Remember, we want them the same, but they don't actually have to be. Again, own schemas. Membership, this is what roles he belongs to, what database level roles he belongs to. Securables, okay, so here is where we would grant permissions at the object level. Okay, so I'm going to hit search here, and I'm going to tell it that I want specific objects, and I want specifically tables. We're going to hit browse, and I want to look at these 3 tables. Okay? Hit OK, and they're now listed here. So now I can grant doc delete permissions on the player position table in the baseball schema. All right, again, we'll script it out, and this time we'll actually run it. And notice again, grant delete on securable to principal. All right. Now, if we go back and look again, because we just ran this, this time when we look in securables, we see that we now have this entered already for us. That's because there's actually a permission down here. Okay? So as long as there is a permission granted to a specific object, you're going to see it in this list. All right, and last but not least, we're going to go over to one of these tables. And again, properties, it's a securable, so we expect to see a permissions tab. And notice doc has delete permission. If I want to add another user or role, then I can search, hit browse, and we're going to go ahead and add it to, well, let's add it to Sleepy. Okay, so we're going to add Sleepy into the list, and now I can see Sleepy's permission. Sleepy does not actually have any permissions right now here, although I can go look and see. Effectively, he does, in fact, have select permissions. Notice we have select permission without a column. This means he has select permission on the table. And then we have a list of the columns because he has permission to each of these columns as well. Remember, there is such a thing as column level security. All right, so I'm going to also grant him insert permission. Now, you see this thing here? You may have already noticed this with grant. If I hit with grant as well, and I'm going to script it because, again, I want to know how to do this. This is an option I haven't tried before. Okay? With grant option. How it adds that to the end. And what that does is that means that Sleepy now can not only insert into this table, but Sleepy can grant the ability to insert into this table to other people, to other principals. All right, so now we're going to go back to our presentation. we're going to look at best practices. Everybody loves best practices, right? All right, I have my best practices broken down into 3 categories. These are really kind of best practices in and of themselves, but we have least maintenance, least surface area, and least privileges. So least maintenance says, let's do as little work as we can. I'm a lazy person. I don't want to make any more effort than I absolutely have to. Now, in order to do that, I'm going to do such things as when I grant my permissions, by preference, I'm going to grant them at the database level. If I grant select permissions at the database level, when somebody adds new tables, I don't have to worry about it. If I can't grant it at the database level, I'll grant it at the schema level, and only as a last resort am I going to grant permissions at an object level, because that's just more work for me. Use roles. Use roles and Active Directory and Windows groups. Use them together. One of the best systems I've ever seen, one of the easiest to maintain systems I've ever seen. They had gone through, and on the SQL Server side, they had application tasks. All right, I have a user. I have a user role. That role has the permissions needed for a user, and I have that in every database. I have an admin role. Again, on every database, there was the roles necessary to whatever tasks. Then, on the Active Directory side, you have your business roles. So I have the junior accountant, and I have a senior accountant, and there's an Active Directory group for the junior accountants and an Active Directory group for the senior accountants. Again, back in SQL Server, we go ahead and we create a principal, a server principal for each of them. And for our junior accountants, they have the user role on the appropriate databases. The senior accountant has the admin role on certain databases and the user role on other databases. And your junior DBA has, again, certain permissions across each of the databases. Now, what that buys us, as permissions change in applications, as they always do, we only had to change that in the roles. The appropriate role for the appropriate task was changed, and we were done. As people moved in and out of the company or changed positions, got a promotion, whatever, their Active Directory membership was moved to the correct groups, and all of a sudden they had the correct permissions. It was all very nice and clean and easy, and it separated out the SQL Server permissions was controlled by the DBAs. The Active Directory portion of it, where their network connections, that was handled by the security people. They moved these people in and out of the correct groups depending on their position. And it all worked really smoothly. Now, last but not least, this is not really a database thing, this is a life thing. Be consistent. Okay? If you do it one way, if you're granting role memberships on one server and you're granting database permissions on another server, and you're using Active Directory on one server and SQL Server authentication on the other, eventually you're going to get confused. Okay, and honestly, it takes a lot longer to train somebody if you're doing something 6 different ways, because of course, as we all know in SQL Server, there is not a single task in SQL Server that you can't do like 3 or 4 different ways. So if you only have to show them, okay, we do it this way, that's easy. If you have to explain to somebody, well, we did it this way on this server, and this way on this server, and this way on this server, and so on, training is a lot harder, and honestly, again, mistakes creep in. So make our lives as easy as possible, keep things as consistent and as simple as possible. Least surface area. All right. reduce the number of places that an attack can come from, or a mistake. Security is also about protecting us from ourselves. So we want to keep our surface area as small as possible. So components of SQL Server, if you don't need them, they shouldn't be active. Now, I've had discussions with people as to whether it is better to install it up front and disable it, SSIS, integration services, analysis services, reporting services, whether they should be installed up front and then disabled, or whether they should not be installed at all. Honestly, I have no stake in either method, but unless you're going to be using it, it doesn't need to be there. Okay, it's a vector of attack, it's a vector for mistakes. For example, you have SSIS installed, and it's there. You're not using it. You don't need it, but it's there. Well, somebody decides as a test case they're going to go ahead and do this really complicated SSIS package, and it uses up all the resources on the server, and in fact loads multiple terabytes of data into this database, and they just brought the server down. Now, their fault for running this really crazy SSIS package, but they shouldn't have had access to it all. I mean, let's face it, if it wasn't there, they wouldn't be using it. The same thing applies for external apps, drivers, etc. If it doesn't need to be, absolutely have to be on that server, then it shouldn't be. All right, that also helps with performance because, the less you've got on there, the more space you have, things are running that don't need to be running, etc. All right, don't create extra databases. Now, this isn't just production, okay? AdventureWorks, my example here, honestly, I've never seen a need for AdventureWorks to be in a development environment. AdventureWorks is great, don't get me wrong, but it belongs on your test environment at home or on your personal machine because it's not really meant to be a shared database, okay? So it doesn't necessarily belong in a shared environment. There are multiple reasons for this. Okay, again, let's say somebody decides they want a bigger test database, so they load a whole bunch of data in there, and all of a sudden there's no room for anything else, or they accidentally do it. Let's say you've got a production database. It's an old legal thing that you had to deal with 10 years ago, but nobody ever got around to deleting the database. Well, then somebody hacks your server, and all of a sudden they have access to all this legal information, and now you have to reopen stuff that's 10 years old. Whereas if you'd just gone ahead and backed it up, stored the backup to archive, and deleted the database from the server because you don't use it anymore, it wouldn't have been an issue. All right, SQL Server protocols. We have TCP/IP, name pipes, VIA, shared memory. Only turn on the ones you want, okay? VIA, you're not using VIA. It's been deprecated. It's hardware specific. Nobody uses it anymore. Shared memory. If this is your production server, you shouldn't be logging into the server anywhere. Shared memory is specifically for connections from the server to the instance. Okay, you connected via Windows and you're opening up SSMS on your server. Don't do that. So shared memory doesn't need to be activated. Name pipes. People do use name pipes sometimes, but it's an older connection protocol, so it's pretty unusual. Don't turn it on unless you actually know you're going to need it. And TCP/IP you're actually going to have turned on unless it happens that this server is only connected from that server. You have an instance where the only people who connect to this instance actually log into the server, at which point you'd turn on shared memory, you turned off TCP/IP. This reduces the number of places a connection can come into SQL Server from. All right? And remember, name pipes is an older system, and I don't know that this is possible. I'm not a hacker, but let's say somebody came up with a vulnerability that is name pipe specific. Well, if name pipes isn't enabled, it doesn't matter. You can't connect. Okay, your server is safe. So the whole point here is to reduce the number of places that a mistake or an attack can come from. Last but not least, least privilege. This is the one you will see in almost every book on SQL Server, all over books online. Don't give them permissions they don't need. Okay, unless you absolutely have to have a permission, you shouldn't have it. That means if you are a developer, for any developers who are connected, I apologize up front, you don't need DB owner. This is far more permissions than any developer ever needs or wants or should want. I had a developer come to me a number of years back. They had accidentally deleted a shared database. They were DB owner, the whole team was DB owner. Well, they'd hit the, somehow, I don't even know how, they'd hit the delete key or something, and they'd managed to delete the database. Well, they were in a panic because, you know, their boss was not going to be happy with them when they found out. Fortunately, I'm the type that backs up even my development databases on a regular basis, and I was able to restore it back to right before he deleted it, or shortly before. So he wasn't in too much trouble, and we very quickly got rid of that level of permission. But here's the thing, DB owner gives you a huge space for mistakes. You can create all kinds of havoc by having more permissions than you really need. All right, granting permissions to views and store procedures rather than the underlying tables, this is a development, a design decision. Remember I was saying this is how SQL Server does it? Okay, we don't actually have access to the underlying tables. What we have access to are system views, system store procedures, etc. I have seen this work great. I have seen places where they don't do this and it's not a problem. Okay, but just pick, again, be consistent. Pick one or the other. Either do all of your permissions at this higher level or don't worry about it and do it at the lower level. Again, design decision. You just need to pick one or the other. All right, last but not least, grant your permissions at the lowest level you can. Okay, if you can grant them at the table level, at the store procedure level, do that. Grant at the schema level if you have to, and as a last resort, grant your permissions up at the database level. Now, when I give this this session live, I'm always waiting anxiously for somebody to raise their hand at this point, because very deliberately, you'll notice, okay, grant permissions at the lowest level possible, and I'm hoping somebody caught this here too. And we go back to, whoops, 2 slides. Don't make permissions more granular than you have to. Okay, those are the opposites, right? I've said, in one case I'm saying grant your permissions at the database unless you absolutely have to grant it at the object level. And the other I'm saying grant it at the object unless you absolutely have to grant it at the database level. So what's going on? Security is all about give and take, okay? It's a process. On the one hand, you have to grant permissions for people to get their work done, all right? On the other hand, you don't want to grant them too many permissions. And on the other hand, and note, yes, that's 3 hands, you want to make your life as easy as possible. You don't want to make any more maintenance work for yourself than you really need, because that just adds to mistakes. So security is all about making decisions, decide what is best for your environment, because this is one of those it depends kind of things, and there's so many variables here that no one can ever teach them all to you. You have to look at your environment and decide what is best for us, and then go with it. And don't be afraid to make changes if you need to. Okay, if it's not working, then change. But you have to make your decisions, and you have to go with what you're going to do, okay? Because honestly, the world is scary, all right? Data is a valuable commodity, and people are trying to get it. They want your data. And we are, if this looks like a target that was deliberate, we are at the center of the target. And if we don't get our security done right, then it doesn't matter what these other groups are doing, okay? They can all be doing everything perfectly, and if we've messed up, then it doesn't matter. But I'll tell you what, if the network it doesn't have their security up to snuff, then it doesn't really matter what we do. Same with server security. It's a very cooperative thing. Work with your server teams, work with your network teams, make sure your security is as safe as possible. Okay? And that's it. So, oh, and here's the quiz I promised. Do we have any questions, Robert?
Thanks, Kenneth. All the questions I was able to answer directly. I would like to share a couple of them real quick. Um, Oscar Noriega asked, "What about linked server security?" And my comment back for that was that that's really a much larger topic in and of itself than what we can cover today. It would probably take a whole presentation just to cover linked server security. But just want to put that out there in case there's anything you want to add to that.
I will start with, you're right, it's at a much higher level than what we were doing today, but what you do need to remember, though, with a lot of linked server security, all you're doing is the basic stuff on two different servers, and from there, that's when you start getting into your more advanced, who's connecting to the next server. But again, it all starts with these basics. It all starts with granting the select permission, the execute permission, and so on.
Okay. Another question I wanted to share was Michael Stanton asked, if you have an Active Directory group set up as a login in SQL, is it possible to see the users who are members of that AD group or log in from SSMS? And I replied that yes, there's a system extended stored procedure called XP underscore login info that you can run, and it'll tell you who the members of that group are.
And I will say that look, at my office, I can't use that. For some reason, the permissions, the way that the network is set up, it's not, I don't have access to it. So yes, you can using that sometimes. Sometimes you can't.
Yeah, that's
Take a look at that.
That's a very good point. I've run into that issue before, and what we had to do to make that available is to have our AD guys mark the groups as readable to all authenticated users in AD.
Right. Another thing you can do is take a look at that sys.login token I mentioned earlier. It's not exactly what you're asking for. It's more the opposite. But take a look at that, and that'll give you might give you some information you'll find handy there.
Okay, and we did, just while we were talking, we did get a question in. Harry Hoffman asked about database create all set to SA. What are your opinions on that?
Say that one more time.
So
I didn't quite
he's
understand.
basically asking what your opinion is on having the owner of the database all set to the SA account.
There are pros and cons. One of the biggest cons I can think of right now is that if you happen to have a database that is trustworthy, and the owner is a sysadmin, then you've just granted anybody who's got create procedure access, kind of keys to the kingdom. They can take control of your server. I'm more inclined to have a user created specifically for that purpose. But I've seen plenty of systems where the owners of all the databases are sysadmins, and usually it's okay.
Yeah, and
Do you have any opinion on that, Robert?
Yeah, I would agree. In my environments, I typically will not allow the trustworthy to be set on any database. So any reason that somebody wants to set trustworthy on a database, there is a more secure workaround for making what they want to do work. So I don't allow trustworthy, and then having SA set as the owner of the database isn't an issue. If you have an environment where you do allow trustworthy to be set I would definitely consider having a non-sysadmin account be owner of those databases.
Or control the permissions on those databases rigorously. I do have one case where I disagree. There's one case where I've worked where we actually did have to use trustworthy. We actually did have to have fairly high-level permissions as the owner, but we created a specific database for the purpose, and the only permissions in there were connect and then execute to that specific store procedure that we had created. So yeah, you can do it. Just be really, really careful with any permissions in that database.
Yep. And that's all the questions we have. So thanks for presenting for us today, Kenneth, and thanks to everybody who attended. This session